Assalamu alaikum rahmatullah. I hope those are watching this video are doing great and having good health by the grace of Almighty. Welcome. This a beautiful class is about the mathematical problem solving techniques of chapter concept of mole. This is beautiful as because I said it earlier that when I sequentially upload all the videos of this chapter, that this is the foundation and this is the basic, and it's all about stoichiometry, the calculations regarding amounts and molecules, atoms and ions. So those who wants to be like a chemist or working in like chemical industries, this chapter and the concept for them is very important. And also you that was watching all my videos, I said it the same thing, that do not skip anything of this chapter. I just got two sort of samples that to let you understand that what type of questions you can see on a question paper, and I hope you already seen it because those students have already completed this chapter. These sort of questions are common. Think about it. The first question is, to prepare edible salt, we know the formula of edible salt is sodium chloride. So to prepare this, 54.5 gram hydrochloric acid is added with 32.5 gram sodium carbonate is given. The question is, which and what amount of substance will remain? So we need to find out the limiting reactant. So if we get the limiting reactant, we will find that what other reactant will remain in what amount. To do it, we need to do the reactions and we must need to balance it. How to do it? Think about the sodium carbonate is reacting with HCl, okay? And then it is producing what? We must put equal sign in both cases to make the atomic numbers, atoms number same. So it will produce sodium chloride plus water plus carbon dioxide. Now you think this is 2, but this is 1, so we need to make it 2. And again we can see this, that this chlorine is get 2, then it should be 2 here. Now the equations are okay. And now we need to think the molecular mass of this reactant. Think about sodium is 23 times 2 plus carbon is 12 plus oxygen is 16 times 3. So if you add all these, we will get 106 for sure. And even if you see the other part, that is 2, hydrogen is 1 plus chlorine is 35.5. So it's 36.5 times 2 is 73. So from my calculation, I can see that 6 grams sodium carbonate is reacting with 73 gram HCl. So if I say that 106 gram sodium carbonate is reacting with 73 gram HCl, now we need to think what is the data. Here 32.5 gram sodium carbonate is reacting with this amount of HCl. So now we need to think based on this data that if 1 gram sodium carbonate will be reacting with this, so 32.5 gram sodium carbonate will be reacting with this 32.5 by 106. Now we need to find it out. We need to find it out that 73 times 32.5 divided by 106 is 22.38. Now we can see that 22.38 gram HCl was required to react with 32.5 gram. Now you see the data. This is the amount that you get from the calculation, that 106 gram sodium carbonate is required. It's reacting with 73. It's my standard data because that is the calculated value. But in actually, what is given, like 32.5 gram sodium carbonate is reacting with 22.38 gram HCl. But you see here is 54.5 gram. That means we can say that sodium carbonate will end. So that that sodium carbonate is the limiting reactant. So it will end, but you see 54.5 gram HCl is there. So 22.38 will be reacting with this amount of sodium carbonate, and then how much, which and what amount of substance will remain? We need to find it out, as 54.5 gram was given, but the reactant is 22.38 gram. So if we get it, that minus 54.5, that is actually 32.117. So 32.117 gram HCl will remain in the reaction medium, and this is the answer of first question. So you see that how we did it. Which and what amount of substance will remain in the reaction medium? This amount of HCl will remain, as because we got this amount of HCl will be reacting with this amount of sodium carbonate, and sodium carbonate will end, but more HCl was there. Okay, and then the next question is that what amount of limestone? This is very important. This is very important. Okay, I'm just releasing 2 also. What amount of limestone? Now a new compounds. Limestone should be burned to get same amount of carbon dioxide produced from the stem. Now you think, this carbon dioxide is producing here, and the molecular mass of carbon dioxide, we know it's 44. So we see this is 44. Now you think, which one should be your standard? You know that sodium carbonate is the limiting reactant. So we should think about this. Why? Because according to the stem, we need to think that how much actual carbon dioxide will be producing. So if we say that 106 gram sodium carbonate is producing 44 gram carbon dioxide. Definitely we are not taking 73 gram. Why? Because this amount is not the actual amount that we are thinking of. We need to think the limiting reactant. So 1 gram sodium carbonate will produce this amount of carbon dioxide. Now you see that 32.5 gram sodium carbonate will produce how much carbon dioxide? So it would be like 32.5 by 106. So if I do the calculation, that 44 times 32.5 divided by 106, that is actually 13.49. So 13.49 gram carbon dioxide will be producing from this amount of sodium carbonate that is fixed. So the question is, what amount of limestone should be burned to get same amount of carbon dioxide produced from the stem in STPS? Because standard temperature and pressure should be counted, as we know that standard temperature is 273.15 Kelvin or 0 degree Celsius or 32 degree Fahrenheit, and the pressure is 1 atmosphere, which is 101.325 Pascal or 76 centimeter mercury column. That is the standard temperature and pressure. I'm just telling it for your memorizations. I know I have explained it in the pressure chapter when I explained this chapter physics pressure, that I explained this STP, and also in Torricelli experiment. So in 13.49 gram carbon dioxide need to be present and need to be produced, and the question is what amount of limestone we need. So we need to think about 13.49 gram carbon dioxide should be produced. So the next reaction is calcium carbonate, that is CaCO3. This is the limestone that is producing calcium oxide and carbon dioxide. Now you think the molecular mass of calcium carbonate is 40 plus 12, 16 times 3 is 48, so it's 100, and this is actually 44 like before. Now you think that my the question was asked that what amount of limestone should be burned. So we are searching for the amount of limestone. So this amount of limestone should be in the right side of your step. So it means that 44 gram carbon dioxide is producing from 100 gram limestone. That is my line. That is my standard line that I need to think of. So we don't start from that 100 gram limestone is producing 44 gram carbon dioxide. No, we need to think that we need to find the amount of limestone. So it would be in the right side. So we can say that 44 gram carbon dioxide is producing from 100 gram limestone. So 1 gram carbon dioxide will be produced by this amount of limestone. So this amount of carbon dioxide will be produced from what amount of limestone? So this is the thing. So 13.49. So the answer is 100 times 13.49 by 44. Now you think the answer is 13.49 times 100 divided by 44. Answer is 30.66. So 30.66 gram limestone is required. That is the answer. And I hope you won't feel any toughness or some sort of nothing is easy. You think that if you feel any sort of problem, write me in the comment box after watching this tutorial. But if you feel okay, this is easy, it's all about your understanding the topics, it's all about your thinking process, that you really understand the theory, how to think. That is the thing. As it's all about the calculations, and this chapter is important because at least one question should come, is usually coming in the question paper. So I hope you understand. So there are two things, and of course in this type of problem solving technique the reactions should be equalized, balanced. So I'm removing it. So think about the next questions, and this is also very common. This is also very common, and you see what is there. The question is 2 beaker is given. Okay, there is 0.5 molar ferrous chloride is kept in a beaker where the solution volume is 100 milliliter. Okay, so we got two pots, A and B. So what is actually available in A pot? What is actually available? We need to think about it. What is the equation that we work for? Like SW equal to SVM by 1000. Can you remember that I've said it already, that SVM divided by 1000 is the equation that we need to work it. And then in A part we see that S is given 0.5 molar and V is given 100 milliliter. And now we need to think about it. What is the molecular mass of ferrous chloride? So the mass of ferrous chloride, FeCl2, we know that Fe is 56 plus chlorine is 35.5 times 2. So this is 71. So what should be the thing? 35.5 times 2 is 71 plus 56 is actually 127. So this is 127. So I have 3 data from A pot. From B pot you see that 5.2 gram, that means W is given. This is the mass of the solvent is given 5.2 gram. And again V is given 250 milliliter, that is the volume of the solution, 250 milliliter. Now you think about the molecular mass, which is already given, that sodium hydroxide. So we need to find it out. Sodium is 23 plus oxygen 16 plus 1. So it's altogether 40. So you got 40, which is the molecular mass of sodium hydroxide. Now we have again 3 data from pot B. Now the question is, what is the molarity of pot B? It's easy, it's given. What is the molarity? So the question was asked, we know that W equal SVM by 1000 if the volume isn't given milliliter. So if you need to find S, so it will be W times 1000 Vm part B. So as we know, the W is 5.2 times 1000. This V is the volume, which is 250 times M is 40. Now we can think about 1020. So this is 4 and 25 is 100. So 100 by 10 is 10. So 10 means 0.52 molar. 0.52 molar. So the molarity of this pot is 0.52 molar. We get the first answer. So I think this is easy. And the second questions that I'm asking right now, it's the common question. That if we mix these two solutions together, which one should be the limiting reactant? Which one is the limiting reactant? And this is the common questions. Finding the limiting reactant in this table. So suppose this solution is given, this solution is given. We need to find the limiting reactant. And we know the concept of limiting reactant is that which one will end. So now we need to think about the reactions. I'm just removing it. So for the first time, if you see these things, that I will ask you to just write it down with your own hand and do practice. So FeCl2, ferrous chloride, is reacting with sodium hydroxide. What will happen? It should be equal. So it will create FeOH2. It means this will be 2, and sodium will react with chloride. So it will be 2 molecules of sodium chloride. And this is the equations. And we must need to write these equations, these chemical equations, in a proper way, and it should be balanced. Now you think, what is the amount or the molecular mass of this reactant? Iron is 56, just together I just did it. So this is 35.5 times 2. I think this is 40, so it would be like 80, and it would be, I just forget, this is 71. Yeah, 71. So 127 I think. Yes, 71. Okay. So it means that from the calculation, 127 gram ferrous chloride is reacting with 80 gram sodium hydroxide. So we can say that 127. Okay? Before going to do that, we need to think it. That, well, I need to say it again. That I just figured out one thing, that here the amount of substance is given. But in part A, the amount of substance is not given. We need to find it out in part A. So in part A, we can see that W, need to find it out. SVm by 1000. So S is the molarity, which is 0.5, and V is 100 times M is 127, and this is 1000. So if I divide it by 10, so it would be 12.7. So if I divide 12.7 into 0.5, 12.7 into 0.5, that is actually 6.35. So 6.35 gram ferrous chloride in the part A. So we got the mass of the solvent, and we also get the mass of the solvent. So now 6.35 gram is given. So now we have the standard line that 127 gram ferrous chloride from the calculation is reacting with 80 gram sodium hydroxide. Now you think 1 gram ferrous chloride will be reacting with this amount of sodium hydroxide. So in reality, in the part A, 6.35 gram was given. So it means 80 times 6.35 divide 127 is the answer. It's not actually the answer. We need to find out the limiting reactant. So 80 times 6.35 divided by 127, which is 4. Okay, 4 4 gram sodium hydroxide. Now this is the time to think which is the limiting reactant. I think that 6.35 gram was in this part. So from the reaction to standardizations, we know that 6.35 gram will react with 4 gram sodium hydroxide. But you see, the sodium hydroxide is given 5.2 gram. That means more sodium hydroxide will remain. That means ferrous chloride will end first. That means the given data, what is the mass, is already there, 6.35 gram, which is reacting with 5.2 gram sodium hydroxide. I mean 4 gram sodium hydroxide. But here 5.2 is given. That means already more sodium hydroxide will be there. So we can say that limiting reactant is ferrous chloride, and that is the answer. That is the answer. So if the question is what amount of reactant will remain in the reaction medium like before, then we see that 4 gram sodium hydroxide will be reacting with 6.35 gram ferrous chloride. So as we have 5.2, so we can minus like 5.2 minus 4, that means 1.2 gram sodium hydroxide will remain in the reaction medium, and that is why as it is remaining after the reaction, so sodium ferrous chloride is the limiting reactant, and that is the thing. Okay, so I hope it's not tough. I'm just trying to give you some very sort of like some sort of common category question solving technique. I actually uploading these videos to make you understand if it is for the first time or if you don't do practice. Actually the main thing is that if you don't do practice, then things will be tough for you. But if you do practice, because you know that practice makes everybody perfect. So if you do practice these things, this will definitely looks easier for you. And it's actually very normal type of questions. There are some advanced level of questions and advanced level of mathematical problems is coming, and I'm coming up with this sort of things together. So see you on the next class and let me know your feedback. Take care.